Welcome to this fourth module of the unit devoted to the instrumental approach in the project ICMAI Awardees Multimedia Online Resources. As announced at the end of the third module, this module will be devoted to the first research works engaging the instrumental approach. The research carried out in the frame of the national project mentioned in Module 1, the thesis by Badr Defouad in Paris and Luc Trouche in Montpellier. These had both empirical and theoretical outcomes. In the national project covering grades 10 to 12, in order to understand better how CAS technology could be productively used and to identify associated conditions and constraints, and important design work was undertaken. This was done relying on the concept of didactical engineering familiar to French didacticians, with the importance attaching it to the epistemological analysis of the knowledge at stake, here engaging both mathematics and computer science knowledge, to the optimization of the didactic potential of the milieu of the teaching situation through the careful choice of didactical variables and forms of interaction, to the a priori analysis of these situations and the contrast with their a posteriori analysis, and paying, of course, the necessary attention to the demands of instrumental genesis. A reflective analysis of this design work is proposed in the chapter I authored in the book edited by Dominique Guin and Luc Trouche, and also in the extended English version they co-edited with Kenneth Ruthven. The covers of this book are shown on this slide. I will illustrate this work with one example. A didactical engineering initially designed for grade 10, but the ERES team in Montpellier, focusing on exact and approximate calculations and the equivalence of expressions. As explained in the chapter mentioned above, from an epistemological perspective, the use of symbolic calculators of CAS software a priori offers interesting potential to rethink the relationship between exact and approximate calculation, both instrumented by the symbolic calculator, to work on the sense of algebraic expression, making it possible to expose students to a much richer landscape of algebraic forms, with a diversity of equivalent and often unexpected forms this expression can take through the use of CAS commands. And to make students sensitive to key issues in the field of symbolic computation, such as simplification and data representation, a sensitivity required by an efficient instrumentation. The didactical engineering is made of 3 lessons. I just briefly comment the last one, where equivalence of expression is explicitly addressed. The 3 series of exercises propose a progression. Equivalence, called equality here, can be checked either by using CAS commands to transform one expression into the other, or to reduce the distance between their semiotic representation and ease the comparison. However, equivalence can also be checked by using the test f of x equals g of x, or f of x minus g of x equals 0. The characteristics of the expressions have been selected in order to generate surprising phenomena whose elucidation should stimulate deep work and discussions involving both the sense and denotation of expression, and to engage both mathematical and instrumental knowledge. I invite you to use one or several symbolic packages to observe what happens. Do you obtain the same results with different symbolic packages? Do the two equality tests work for all expressions? Such situations are not just adaptations of paper and pencil situations. They aim at restoring an adequate balance between the epistemic and pragmatic dimension of instrumented praxeologies. They inspired other researchers who have more systematically studied their potential than had been possible in the framework of this project. This was the case, for instance, with the substantial didactical engineering designed for grade 10 students, Canadian students, by Caroline Kiran and her colleagues, which was experimented in 6 different classes. As initially claimed, beyond empirical results, these first research works also contributed to the theoretical development of the instrumental approach. The thesis by Badr Defouad illustrates this point well. He investigated the instrumental genesis of the variation of function along the year-long didactical engineering for 11 graders who had collaborated design with Jean-Baptiste Lagrange, Michel Duperrier and Guy Juge, the 2 teachers of the experimental classes associated to our research team in Chartres and Rennes. Badr Defouad evidenced the complexity and slow progression of this instrumental genesis that entails the emancipation from a graphic calculator culture, leads to changes in the function of the different applications, home, graphic, table, highly depends on the student's relationship both with mathematics and with technology. He also identified specific phenomena, zapping between representations and comments, overchecking, explosion of techniques, and clarified their influence on instrumental genesis. Let me illustrate some of these phenomena with the example of a student's interview after a month of use of the calculator. During this interview, among other questions, the students were asked to produce a graphical representation of this rational function and to study its variation. Here is the work of one student. As already mentioned in Module 2, as was the case for most students, this student was not able to get an accurate representation of the function. He stopped with the graph, you can see here, and moved to the home application to find the derivative and factorize it. However, he did not use this factorized expression to find the sign of the derivative and deduce variation as could be expected. Rather, he came back to the graphic application, entered the expression of the derivative, and tried to connect the 2 graphic representations, increasing, decreasing parts of the graph of f with positive, negative parts of the graph of f prime, maximum and minimum of f with zeros of f prime, checking then his conjectures with the table application and again with a zoom on the flat part of the graph. We observe here characteristic of a transition phase in the emancipation from a graphic calculator culture and typical zapping and overchecking phenomena. These phenomena attracted the attention towards the institutional management of instrumental techniques. Looking back at the data, we showed that instrumental techniques were legitimate in the experimental classes, but they were not submitted to the work of selection, consolidation, and routinization, which is standard for paper and pencil techniques. They were not part of the institutionalization process. They remain private objects, which were not officially worked out. Thus, the labeling of semi-official technique introduced by Badr Defouad. The research also allowed us to identify factors contributing to this state, such as the diversity of instrumental techniques available to perform a type of task offered by the symbolic calculator, and the teacher's desire to show this diversity. The mixture of computer and mathematics knowledge engaged in explanation and justification, that is to say, the logos block of associated praxeologies, including often extracurricular mathematical knowledge. The problematic accessibility of some necessary technical information, and the distance with ordinary values of mathematics teaching. This knowledge allowed us to move conditions and adapt the didactical engineering for the second year of experimentation with impressive effects on the dynamics of instrumental genesis. And it also contributes, of course, to enrich the theoretical block of the instrumental approach research praxeologies. I move now to Luc Trouche's doctorate. In the second module, I mentioned that from the beginning, Luc Trouche adopted a slightly different perspective, more directly inspired by the theory of conceptual fields. This had direct influence on his thesis, focused on the conceptualization of limit of functions with graphic and symbolic calculator, which was defended in 1996. One important contribution of this thesis is indeed the identification of schemes of instrumented action and usage schemes, and the way the move from graphic calculators to symbolic calculators during the academic year affected these schemes. Three main schemes of instrumented action for finding limits were identified by Trouche. Scheme L1. The limit is inferred from the search for numerical values in the neighborhood of the limit point, using the table application, for instance. Scheme L2. A first gesture in the numerical register to select a graphic window is followed by an interaction between the numerical and the graphical registers. Scheme L3. The use of the limit command of the symbolic calculator. Two of these schemes are, of course, associated operational invariants in form of theorem in acts. For instance, the following. If f of x takes much larger values than x, then the limit of f is infinite. If the function increases with great speed, then the limit is infinite. In the thesis, schemes are related to different students' profiles, and it is shown that the same scheme can have different functions according to the students' profiles. It is also observed that for some types of students, the move to the symbolic calculator and the development of L3 goes along with an impoverishment of the instrument. The limits simply become the number or expression one can read using the limit command of the calculator. Among the utilization schemes is, for instance, the scheme of approximative detour, consisting of using the tool to find an approximate value when the exact value is not directly accessible. It can have various functions. A determination function when the approximate value is taken as a value, but also an anticipation or checking function when it is just a step in the process of getting the exact value. For instance, for finding from which rank the terms of a convergence sequence are in a given neighborhood of the limit. Functions given to this depend on the schemes of instrumented action these utilization schemes are part of, and also on students' profiles, as shown by Trouche. We can also observe in this doctorate the importance attached to the socialization of instrumental genesis and the organization of classroom configuration allowing this socialization, such as the use of the view screen device to project the calculator screen, and the devolution of a specific role to a student called the Sherpa student, in charge of piloting the overhead projector calculator in front of the class. This will lead to the concept of instrumental orchestration, a concept that will quickly become a central concept of the instrumental approach. I will stop here for this module, just mentioning that paper published at the turn of the century, the books published in 2002 and 2005 will contribute to the consolidation and the rapid international dissemination of the instrumental approach, and to its combination with other theoretical frameworks. Thank you.